Let's revisit the imaginary unit I. So if we look at the highlighted line in yellow, we can see there's two main pieces of information we need when we work with the imaginary unit I. So remember, I by itself represents the square root of -1, which is not a real number. That's why we use the imaginary unit I to denote the square root of -1. Now, when we square the number I, and we obtain I squared, then we actually produce the real number -1. So those two definitions are going to be really important as we simplify the examples below. Let's look at the first example where it shows the square root of -25. Now, if you were to type square root -25 in your calculator, you'd be given an error message because it's technically not a real number. We need the imaginary unit I to express the square root of -25 because there is no real number that I can square, meaning there's no real number I can multiply by itself and obtain -25. That's where the imaginary unit I comes in. So we can see the first thing we do is we rewrite the number -25 as the product of 25 times -1. Both numbers are still in the radicand. So now I have the square root of the number 25 times the number -1. Now, using my multiplication property of radicals, that becomes the square root of 25 in its own square root sign times the square root of -1 in its own square root sign. So if I have the radical of a product, it is equivalent to the product of the radicals. Let me say that again. The radical of a product is equivalent to the product of the two different radicals. And that allows me to finally provide an answer using the imaginary unit I. So when I have the square root of +25, that's 5. But then when I have the square root of -1, that is denoted by the imaginary unit I. So to simplify the square root of -25, the answer would be 5i. All right, let's take a look at part A. If I have the square root of -9, I want to rewrite it as the square root of +9 times -1. And then I can split up the radicals. Square root 9 times square root -1. And then the square root of 9 is just 3. And then the square root of -1 is I. So my answer is 3i. Let's look at part B. The square root of -3. Again, this is not a real number. So I'm going to rewrite 3 as 3 times -1 underneath my radical sign. And then I split it up as the product of two radicals. Square root 3 times square root -1. Now, the square root of 3 cannot be simplified any further. It's just the square root of 3. But the square root of -1 can be written as I. Now, there's two ways I can combine these and write my final answer. I can put I as the first thing I write, as like the coefficient of the radical, and write it as I square root 3. I prefer this way because then there's no confusion that the imaginary unit I is definitely not part of the radicand. But some people like to write the square root of 3 first. But notice what I'm going to do. I'm going to put a little hook there at the end of the square root sign to show that the square root sign ends, and then the I is definitely not included within the square root sign. So you could write it as the square root of 3 times I with the I afterwards, but make sure it does not look like your I is underneath your radical sign with the 3. So either one of those answers is appropriate. All right, in part C, I first need to think about that the number 80 can be simplified, or I should say the square root of 80 can be further simplified. So I'm going to rewrite 80 as 16 times 5, but then since it's -80, I want to include the factor of -1. So I've rewritten -80 as 16 times 5 times -1. Now, I chose to factor the number 80 as 16 times 5 because now 16 is the largest perfect square that is a factor of 80. So that will allow me to simplify the square root even further. So the square root of 16 gives me 4. The square root of 5 cannot be simplified, but the square root of -1, the square root of -1 is the imaginary unit I. So we can multiply 4 times I because the number 4 and the imaginary unit I are no longer included in the radical, but then we still need the square root of 5 for our final answer. So 4i square root 5. Let's take a look at part D. Okay, so now we're going to test the skills we just learned in parts A, B, and C. So in part D, I have 6 plus square root negative 4. Well, 6 is the real number 6. There's nothing to do to the number 6. But the square root of negative 4, since 4 is a perfect square, becomes 2. But since it's negative 4, it's really 2i. So that's it, 6 plus 2i. And I do not combine those because the number 6 is a real number and 2i is an imaginary number. So please don't add those together and call that 8i. I'm not even going to write it down because I don't want you to see it. But you're not going to add 6 plus 2. It's just like combining like terms. 6 is a real number, 2i is an imaginary number, and they are not alike. All right, let's look at part E. In my numerator, I have 10 plus the square root of negative 25. So since 25 is a perfect square, that becomes 10 plus 5i over 5. Now, I do have some further simplification. If I look at the numerator, 10 plus 5i, the terms 10 and 5i share a GCF of 5. So I will factor out that 5. So my numerator becomes 5 times the quantity 2 plus 1i, or just 2 plus I. But now I can divide out the 5s. So my final answer is just the expression 2 plus I. 2 is the real number, I is the imaginary number. They're separated by a plus sign. No more simplifying is needed. All right, and finally in part F, I first want to address the square root of negative 18 because the square root of negative 18 can be further simplified. So I will rewrite negative 18 as 9 times 2 times negative 1. Since 9 is a perfect square, I will simplify the square root of 9 to 3. And since I also have negative 1 under the radical sign, I will have an I in my answer. So on the outside of the square root sign, I will have 3i, but the 2 will remain under the square root sign because the square root of 2 can no longer be simplified. So now let's go back to my original expression. It becomes 2 plus 3i rad 2 all over 6. Now, I could leave my answer that way, or if I split it up into 2 fractions, I can do some further simplifying. So my first fraction would be 2 over 6, and then I would separate the 2 fractions with a plus sign, and then my second fraction would be 3i rad 2 over 6. So the 2 fractions share a common denominator of 6, but they can each be simplified differently. So the fraction 2/6 becomes the fraction 1/3, but in the second fraction, 3i rad 2 over 6, I can simplify the 3 over 6 to 1 over 2. So that fraction becomes I radical 2 over 2. So I can write my answer as 2 separate fractions. Now they don't have the same denominator because they simplified a little differently. So I can write it as 1/3 plus I rad 2 over 2, or you could have left it as 2 plus 3i rad 2 over 6. I hope this helped you. Remember your rules and your steps for using the imaginary unit I.